56. Let's read it. For the reaction, CH4 gaseous plus 2O2 gaseous gives CO2 gaseous plus 2H2O liquid. Delta H is given by. Students, we all are aware that delta H is equals to delta U plus delta NGRT. Here delta Ng represents number of gaseous products minus number of gaseous reactants. So let's calculate delta Ng for the given reaction. Here number of gaseous product is 1 minus number of gaseous reactants, which is 3, that means minus 2. So let's put the value of delta Ng in the given equation. Delta H is equals to delta U minus 2RT. That means the correct answer is option number 2. Moving to next question. In which of the following processes entropy decreases? Evaporation of water. Students, during evaporation of water, the randomness increases. As a result, entropy increases. Melting of ice. During melting of ice converts into water. As a result, again, randomness increases, or we can say that entropy increases. Moving to next. Sublimation of naphthalene. Here, solid naphthalene converts to gaseous naphthalene. That means entropy again increases because randomness increases. Moving to last, condensation of steam. Here, steam gets converts to water. That means the randomness is decreasing. As a result, we can say that entropy also decreases. So the correct answer is option number 4. Moving to next question, which is 58. Let's read it. Bond dissociation enthalpy of H2, Br2 and HBr are 435, 192, 368 kilojoules per mole respectively. Enthalpy of formation of HBr is. Students, first of all, I'm writing the reaction of formation of HBr. Half H2 plus half Br2 gives HBr. Since student, I have written here 1 mole of HBr because enthalpy of formation is for 1 mole. So let's calculate enthalpy of formation, which is equals to summation of bond energy of reactants minus summation of bond energy of products. So here reactants are H2 and Br2. So here half into bond energy of H2 and Br2, which is 435 plus 192 minus bond energy of HBr, which is equals to 368. Student, I have multiplied and solved the entire equation. Ultimately, this is equals to minus 54.5 kilojoule per mole. That means the correct answer is option number 2. Moving to next question, which is 59. For a reaction to be spontaneous at all temperature, which of the following set of conditions is true? Student, first of all, for this question, we need to understand that for spontaneous process, delta G must be negative, that is less than 0. And also there's a formula to calculate delta G. I'm writing it. Delta G is equals to delta H minus T delta S. Therefore, is delta H is negative and delta S is positive, no matter what the temperature is, the delta G will be negative, or we can say that the reaction will be spontaneous at all temperature range. That means if delta H is less than 0 and delta S is greater than 0, the reaction will be spontaneous at all temperatures. That means the correct answer is represented in option number 2. So here I'm writing option number 2. Moving to next question, which is question number 60. Let's read it. At 47 degrees Celsius, latent heat of fusion of a compound is 11.2 kilojoules per mole. The entropy change for fusion process of the compound is. Student, the formula to calculate entropy is enthalpy, or the heat upon time. Since the latent heat of fusion is 11.2, Let's convert into joules. So 11200 joules, and the temperature is given in degrees Celsius. So we'll be converting this into Kelvin, which is equals to 320 Kelvin, which ultimately equals to 35 joule per mole per Kelvin. That means the correct answer is option number 3. Moving to next question.